Within this real-world experiment, students will be able to discover the difference between qualitative and quantitative data, collect, organize, and interpret data, and use their data to explain the transfer of heat energy and aerodynamic heating. For this experiment, students will require the following materials: a science notebook, safety goggles, round latex balloons, plastic balloon pump, hand-filled infrared thermometer, assorted latex balloons, and assorted materials. For safety precautions, be sure to wear safety goggles to protect your eyes and use infrared thermometer with care. To start this experiment, have students engage in qualitative data, which is information that describes or defines characteristics, allowing students to draw inferences and discover patterns. First, give the latex balloon to each group and ask students to describe the physical attributes of the balloon in their science notebooks. Second, using a balloon pump, one student in the group should inflate the balloon while other students safely use their sensors to gather information about changes in the balloon as it inflates. Next, have students begin to explore quantitative data by introducing the different types of quantitative data that can be counted or measured. First, give each group of students a handheld infrared thermometer. Give them a few minutes to practice using the thermometer to gather the temperature readings of objects around the room, such as a person's hand or a bottle of water. Then allow students to inflate the balloons, pumping as quickly as possible but not overinflating so the balloons pop. Record the temperature reading as the balloon is inflated. When full of air, maintain a firm hold on the balloon, and quickly allow the air to escape. Record the temperature as the balloon deflates. Let students conduct several trials and allow them to create a data chart to represent the data collected for each trial. Here, students can calculate the mean, median, and mode for each range and also make inferences about the patterns they are seeing. Some students might discover that keeping the infrared thermometer positioned at a specific spot on the balloon while inflating it is not easy, so we encourage students to use different materials they can find to design a system or apparatus that would stabilize the balloon while inflating it, following the steps of the engineering design process. Encourage students to be creative and test their prototype designs. Be sure to let them reflect on their process. By engaging and exploring aerodynamic heat and the engineering design process of students are able to further understand aerodynamic heating by creating a similar scenario in this experiment. Balloons with the greatest temperature difference between inflation and deflation stages are more efficient since heated air spreads over a larger surface area, lowering the temperature faster. Be sure to allow students to reflect on their process of designing and modifying their stabilizing system while also explaining, extending, and evaluating their knowledge of the subject.